Hello everyone and welcome to Multiplication with Complex Numbers. So again, you may hear complex numbers called imaginary numbers. So the key here is you want to multiply by using your distributive property when necessary and treat the I as we would treat any other variable. Also remember that I squared outside of the radical, or I squared, equals -1. And then simplify. So if you have a negative underneath the radical, you want to change it to I squared, multiply it out, simplify, multiply it out. If you have an I squared outside of the radical, you want to change that to -1. Look at a few examples here. This first example, we have the square root of -2 times the square root of -7. Now, what you cannot do is to multiply those numbers as they are and call it the square root of +14. So you have to change those negatives to I squares. When dealing with multiplication, it's probably easier to go ahead and simplify those I squares. So you would have -1 from that I square, or I'm sorry, the square root of I square is I. The square root of that second I square is also I. And then 2 times 7 underneath your radical. So you have I times I outside of the radical, which is I squared. And 2 times 7 is 14. And then remember, if you have I squared outside of your radical, then you change that to -1. So that just becomes -1, or negative square root of 14. So we changed the negatives that were underneath the radical to I squares, took the square root of each one of the I squares, and then simplified. Now in the second example, 7i times -9i, we don't have any square roots, so we just want to multiply that out. So you're multiplying 7 times -9 and I times I. So -63 I times I is I squared. Remember, I squared outside of your radical, you change that to -1 to simplify it. So -63 times -1. And that negative times the negative would make that +63. Okay, next example, we have 6i, and then in parentheses, we have 2 minus 3i. So we're multiplying a monomial times a binomial. So remember, we have to use the distributive property to do that. So I'm going to multiply the 6i times 2, and then the 6i times the -3i. And remember, I times I would be I squared. Okay, now since I have this I squared on the outside of my radical, that's not underneath the radical, remember what we need to do with it. We need to change it to -1. Okay, so now that gives me 12i plus 18. But we want to write this in a plus bi form if we have that constant term and that I term. So that will become 18 plus 12i. Okay, let's look at a couple more examples. Right here we have 6 minus 3i squared. So I'm going to use my shortcut for this binomial squared. Remember the shortcut? The first term squared minus 2 times the terms plus the last term squared. So that would give us 6 squared minus 2 times 6 times 3i plus 3i squared. Now you can rewrite that as 6 minus 3i times 6 minus 3i and use FOIL or the full distributive property to multiply it out. So that gives me 36. 6 times 3 is 18 times 2 is 36i plus 3i squared is, just square each one of those factors, 9i squared. So again, we have that I squared that's not underneath the radical. So we need to change that to -1. So that would become just a -9. Combine the like terms. The 36 minus 9 would give us 27 minus 36i. Okay, so we have another special multiplication with this last problem here. We have 6 plus 2i times 6 minus 2i. That's the multiplication of the sum and difference of binomials. So a plus b times a minus b equals the first term squared minus the second term squared. Or you can use the full distributive property or FOIL to multiply it completely out. Okay, so using the shortcut, that will give us 6 squared minus 2i squared. 6 squared is 36. 2i squared, square each one of those factors, be 4i squared. I square outside, that's not underneath the radical. So that changes to -1. So minus 4 times -1 changes to +4 or +4. Final answer, 40. Okay, hope you found the video to be helpful. Thank you.